In this video, we're going to talk a little bit about absolute valued inequalities. These inequalities correspond to regions on the numbered line, just like all the other inequalities. So I think the best way to start this is maybe to review what absolute value actually means, and maybe we'll solve an absolute valued equation. So we know that if I have, like, for a number a, the absolute value of a, it gives us, this is what it says. If a is negative, make it positive. So if it's negative, just take the negative sign away. And if a is positive, just leave it alone. Positive, leave it alone. So maybe we'll work an example of a absolute valued equation. So let me come up with one real quick. Let's say we have 5 absolute value of x plus 3 minus 1 equals 2. So my goal is to solve for x. So we'll do this as an example. Solve this. So when working with absolute values, we would just solve this like a normal equation until we get just the absolute value on the left-hand side. So our goal, get absolute value, in this case of x plus 3, on the left-hand side alone. So we can add 1 to both sides, and I'll have 5 times absolute value of x plus 3 is equal to 2 plus 1 is 3, and I can divide both sides by 5 and have that absolute value of x plus 3 is equal to 3 over 5. Now once I have this, my next step is to think about what absolute value means. So I set positive and negative, whatever's in the absolute value, so in this case x plus 3, equal to the right-hand side. So what I mean by that is I have x plus 3 equals 3 over 5, and negative x plus 3 equals 3 over 5. And these will both be solutions to the equation. So I do positive and negative separately. Okay, so x is going to be equal to 3 over 5 minus 3, subtracting 3 for both sides here. And then I challenge you to verify that this is going to be 3 minus 5 over 5, which is going to be negative 2 over 5. Sorry. And then I challenge you to verify that this is going to be negative 12 over 5. Okay, similarly over here, I can distribute this negative. I have negative x minus 3 equals 3 over 5. Add 3 to both sides. I have negative x equals 3 over 5 plus 3. I challenge you to verify that this means that negative x equals 18 over 5, so x equals negative 18 over 5. Okay, if you're confused on what I did with those fractions there, I gave them a common denominator to add them. Check out my video on working with fractions if that confused you. Okay, moving on. So let's think about what absolute value inequalities are kind of saying. So if I'm taking u to be some expression of x. So I might have whatever in here. I might have, for example, like x plus 3 might be u. So I might have the absolute value of x plus 3. Or I might have the absolute value of x plus 5. Or I might have the absolute value of 2x minus 5, right? It doesn't matter what's in here. This just happens in general. If my inequality has the absolute value of u is less than c, then u is between negative c and c. So what does that mean? If this is negative c and this is positive c, and 0 is here, u is somewhere in this interval, okay? If absolute value of u is greater than c, that means that u is less than negative c, or c is less than u. So if this is negative c and this is c, u is somewhere here, or u is somewhere here. It's not in between negative c and c. Okay, so let's apply that to some problems here. So for example, 3 times the absolute value of x plus 3 is less than or equal to 9. So I need to do the same thing that I would do to solve an absolute value equation. So my first step is to get the absolute value expression on the left-hand side alone. So get, in this case, x plus 3 in absolute value on the left-hand side alone. Okay, so I can divide both sides by 3 and get x plus 3 less than or equal to 9 divided 3 is 3. So I just divided 3 on both sides. Actually, let me rewrite this in yellow. So I have absolute value of x plus 3 is less than or equal to 3. And now what I do is do plus or minus, right? So I set positive and negative in the inequality. So we'll set positive x plus 3 less than or equal to 3, and negative x plus 3 less than or equal to 3. So this gives me two separate expressions. So I have x plus 3 less than or equal to 3, negative x minus 3, distributing that negative, less than or equal to 3. On the left hand here, I can subtract 3 from both sides and get that x is less than or equal to 0. And on the right hand side, I can add 3 to both sides and get that negative x is greater than or equal to, less than or equal to, adding 3 to both sides, 6. So dividing both sides by -1, x is greater than or equal to -6. Remember that when I multiply or divide an inequality by -1 or any negative number, I flip, because I divided or multiplied times or divide by a negative. Okay, so my solutions are x less than or equal to 0 and x greater than or equal to -6. So on a number line, if I was to draw what this looks like, if this is the point 0 and this is the point -6, x is less than or equal to 0, so I include 0. It's less than or equal to 0, and it's greater than or equal to -6. So I also include -6. So my solution would be the interval -6, 0, including -6 and 0, the closed interval. Okay? Great. So moving on, we'll do this example as well. So remember, my first step is to just get my absolute value expression on the left-hand side alone. So I can, to do that, subtract 3 from both sides. So I have -1/3. Absolute value of x plus 2 is greater than is greater than 2 minus 3 is -1. And then I multiply both sides by -3. So I have x minus 2 is less than 3, right? Because I divide or multiplied by -3. So I flip the sign. I flip the inequality, rather. Okay, now from this, I separate this into two cases. I have x minus 2 less than 3, and negative x minus 2 less than 3. Yeah? So I can add on the left here, add 2 to both sides, and I get that x is less than 5. And on the right hand, I can distribute this negative and get negative x plus 2 less than 3. Subtracting 2 from both sides, negative x is less than 1. Multiplying both sides by the -1, I get that x is greater than -1. Remember, multiplying by a negative, flip the sign. So this tells me that x is x is less than 5 and strictly greater than -1. Okay, so we're talking about, if we think about a number line here, say this is -1, and let's say this is 5. X is strictly greater than -1, so we don't include -1, and we're greater than -1. Okay, and x is strictly less than 5, so we don't include 5, but we're less than 5. So it's all of this space in here. So our solution interval is the open interval, because I'm not including -1 or 5, from -1 to 5. And this would be my solution. Okay? And that kind of wraps up what I have to say about absolute value inequalities. Thanks. If you consider, if you found this video helpful, please consider liking and subscribing. Thanks.